Okay, problem 14 from chapter 21. Now we're talking about geometric optics. We're given two mirrors with an angle of 50 degrees between them. Theta 1 is equal to 50 degrees. We're told that in the problem, a light is shown parallel to the bottom mirror. Right here, it bounces off the top mirror, comes down, and then makes an angle with the bottom mirror, theta 2. And we want to know what theta 2 is. Okay? So, we have a thing called the law of reflection. Law of reflection. And that states that if you have a smooth surface and a light hits it, it's going to bounce off at exactly the same angle that it hit it, right? Essentially, there might be some formalism that I'm missing here, but these are going to be the same angle. That's the basic idea, right? Okay, so using that, we can actually determine now that we know this is parallel to the bottom mirror, so it's going to be hitting this mirror at the exact same angle as this angle here, because this is horizontal with this. Like, this is the horizontal, right? This is also the horizontal. So these are the same angle. This we'll call theta 1 here. Okay, and then we have some unknown angle here, beta. But is it unknown, really? I mean, because look, we have a smooth surface. This is a mirror. We have a light beam being shown onto the smooth surface, and it bounces off. So by the law of reflection, it should bounce off at the same angle that it makes over here. This should be the same angle, right? Because this is our law. So then, by that logic, beta is equal to theta 1. So now, look at this. We have a triangle, right? We have another unknown angle down here. We'll call this gamma for now. Gamma. There we go. Okay. And so a triangle, when you add up all of the angles, when you sum up these angles, they should sum up to 180 degrees. So then, so I can find my pen. There it is. So then, 180, I don't know how did this happen here. There it is. Equals theta 1 up here. Sorry, this equals this. So theta 1 plus beta. Theta 1 plus beta, right? We're adding these up, these angles. Theta 1 plus beta plus gamma. Right? And we know that theta 1 is 50 degrees. We know that beta is also 50 degrees. So that's 50 plus 50 degrees, right? Plus gamma, so that's 100 degrees plus gamma. And now we solve for gamma. Gamma is equal to 180 degrees minus 100 degrees is equal to 80 degrees. So this angle here is equal to 80 degrees. Now look at that. By the law of reflection, since this beam is coming down here, bouncing off of this mirror, which is a smooth surface, we can use the law to determine that theta 2 is equal to gamma, which means that theta 2 is equal to 80 degrees, which is what we were asked to find. Next problem, number 17. We're given two parallel mirrors, and then we have a beam of light being shot from like the very bottom right here, and it makes an angle alpha with the horizontal, right? So it comes up here and it bounces off this mirror, and then it's going to continue doing so until it leaves, because these actually have a distance of 1 meter. So the total distance, I don't know why that's working. I'll just use the laser, right? So this distance is 1 meter. This distance is also 1 meter. It's not to scale, obviously, but we won't worry about that right now. That's not really that important for this problem. We just know this is a meter, this is a meter, right? Also, we are told some information. Alpha is equal to 5 degrees. We're also told the length is 1 meter, and then that's equal to the distance across, which is 1 meter, which I've already gone over. Great. Now we want to know how many times is this thing going to bounce around before it exits. So how many times is it going to bounce off the left side, and how many times is it going to bounce off of the right side before it leaves? So first thing we need to do is figure out what is this distance here, right? This distance. We know this one is x, right? This would be our y. So we can use our trig formula, tangent theta is equal to y over x, which is equal to y over 1 meter, right? So that means that y, this distance here, is equal to 1 meter times tangent 5 degrees, and that's going to be equal to 0.08748 meters. Okay. Now, I don't know, we'll need this in a minute, but not yet. So the total number of reflections that it's going to make is going to be then 1 meter, 1 entire meter divided by this distance, right? However many times it can work its way up that distance up both sides. So that's something we can figure out pretty easily. That's 1 over 0.0875, we'll call it, and that gives you about 11.4, which means that that's going to be 11 total reflections for the system. But that doesn't tell us how many is on each side, right? So we want to know how many it bounces off of each side. And so let's look at this real quick. So we have this. So on the left side, we're going to have at least, this is 1, right? We're starting from here. And then we'll just add 1. This will be our starting point. We move up the distance. But guess what? Like every time this thing comes over here and then bounces back, it's actually going to be 2 times y. It's going to be 2 times the distance. So this distance here is 2 times y. Right? So then for the left side, what we're going to do is write out, let's say 1 minus, oops, that's wrong. 1, well, we'll just add 1 at the end. Okay, so for the left side, we'll divide 1 meter by 2 times 0.0875. That gives you a value of 5.21, and then we had to add an extra 1, right, because we kind of just skipped that. We said it's going to come up this many times plus this one that it did initially, so that's 6.21 reflections, which means on the left side, it's 6 total reflections. And then on the right, we've already lost this distance, so it's just going to start from here. And so then we take 1 meter minus this little distance here, and so we'll go 1 minus, so we'll say right side. This was the left side, this is the right side. Now 1 minus 0.0875 over, remember it's 2 times the distance because it has to bounce and come back, so it raises up that much, and then it's going to give us a value of, again, we 5.21. Right, this is 5.21. I actually wrote this down. This was actually closer to 5. This original value was much closer to 5, but it was still over 5. It was actually almost exactly 5. So it's 5 plus, and this will be 6. So there we go. So that's 6, so I had to fix that because I wrote that down a little bit incorrectly. It's 5, and this is 5.21, so this is 5 total reflections on the right side. Okay, so on the left side, we have 6 total reflections. On the right side, we have 5 total reflections for a total of 11 total reflections, and that makes sense, right? Because the first reflection is on the left, and then it goes up. All right.